Hi everyone, what's up? It's Gregor here. We are watching Not Only Code. In this mini video series, we will write our own unit test framework in Python in around 100 lines of code. The code that we'll write is quite straightforward. Even if you're intermediate Python developer with maybe 1 year of experience, you should be able to follow most of it. There will be some more difficult parts, but I will explain deeply what each line of code does. Let's start. Before we start writing code, let's see what is actually a unit test framework. So the test framework can consist of a few elements. It can contain a test runner, it can contain assertion library, and it contains some functions for a test structure. Not all test frameworks include all these three elements. Sometimes there are only test runners, sometimes the test framework doesn't have assertion library. But in our project, we will try to build all these three parts. In this video, in this part of this series, we will make it so that we can pass a directory or a list of files there. It will find the tests, it will execute each of the tests, and it will print the results whether the test is successful or whether it fails. Below the video, you can find the link to the source code where you can find all the examples, everything that we're building. And now let's start writing code. So we have two files for now. We have a file called runner.py that is empty, and we have a file with two tests. We have test success that will assert true. We have test failure that will assert false. So this one will be failing. Now we want to run these tests. So let's start by something very simple where we will just run these functions. So in the runner, we need to import these functions. So we will do import full test. And now we will run these two functions. Let's run this file and see that we have an error, the assertion error. This is expected because we have the test failure here that asserts false, and that throws an exception. Now, after it throws an exception, of course, nothing will happen later, so our program will stop working. Now, we need to then wrap this so that if a test fails, the other tests can still continue. So let's try. Let's add a simple method. Now, if you run our test, we will only see the test failed message, which is great. Now, if we stop testing the failure, it will not print anything, which means that the test passed. So in case the test succeeds, we will print the test succeeded. And now if we just run this test, it will say test succeeded. But this part is very tedious. We don't want to add every test function to the runner. We want the runner to find what the tests are there and to run them automatically. So let's change that. First, let's create a tests variable. Now we can do this. So here, test represents a function that we keep in the test variable. Test failure is a function object, and here we can just execute this function. Let's run it. And we see that tests failed because of our test failure. Now what also we can do is we can say which test we are running. You see that we are running test failure and that test failed. What happens is that our test success never runs, and the reason is that we have assertion error around all the thing here. So as soon as one test fails, we just stop and say test failed. Now we will change it so that each test runs independently, and even if one test fails, the other tests will still be running. So we will move the loop to the top of the function. And now we can run it again. You see, now we see running test failure, and it says test failed, and then we say running test success, and it says test succeeded. But that's not true, right? One test succeeded, but the overall test failed. So let's create a success variable here. And then, if at least one test fails, we will say success is false. Now we have success true, and as soon as one test fails, we say success is false. And then in the end, if success is false, then we'll say test failed. So if at least one test fails, we'll say the test failed. Now if we run it, we see running test function test failure, running test function test success, and we see tests fail. That's an improvement, but we still have these test functions here written explicitly. And now what we want to do is we want to find them automatically. So let's say that we will detect what functions are in this bool test module, and as long as the function starts with the word test, we will consider it a test function. In order to do it, we will use a method called getMembers from inspect package. GetMembers will allow us to find all the members, all variables, all functions, all classes in the module that we pass there. So we will pass the bool test module there, and we will say, give us all the members that are functions that start with the test underscore. And then we will assume that these are the actual tests that we want to run. If you've never used the inspect module, make sure to check the documentation. It's very interesting. But for now, let's continue. So here we'll say return m for m in getMembers bool test. Now, what it returns is every member is a tuple. It consists of the name of the member and the actual value. So what we want here is not all the members of a module. We want only those members where the value is a function. So let's check it this way. If m1 is a function, and we only want those functions where the name starts with test underscore. Now here we could return just the function, not a tuple, but actually this tuple with the name might be helpful. So let's do it this way. And here we'll say test name, and here we will execute test function. Let's run it to see what happens. So you see it works, but also in comparison with the previous way that we ran it, you can see that the name of the function looks nicer. Before we got the whole address, etc. Now we are getting just the name of the function, which is a nice bonus. We're still missing some piece of information here. We see which tests are running, but we do not see which test exactly failed. So let's fix that. Now we duplicated a little bit of the code, but we have a nice information, failure or success. Now we still have a problem here. You see, I've got this other file that is called number test, and this file contains another set of tests. If I run the Python runner, it only runs the Boolean tests. So if I want to run the number test, I have to replace the bool test here with the number test, and I have to replace it here. And now if I run the Python runner, it will run the number test. But that's really tedious, right? We don't want to hard code the modules here. We don't want to import them explicitly because we would have to add it every time we add a new module. What we want is something like this. Add the bool test here, and that should run bool test. Of course, for now it will not work. It's still running the number test. So let's make that happen. First, we'll pass an argument to our run function. It will be the argument that is passed from the command line. For now, we need to import our sys, and we need to add this argument here. So that will be our file. Of course, that will not do anything. So now we have to turn that file path, we have to turn that string with the path to the file into a Python module that is considered a real code and that can be executed. This will be the most challenging and tricky part of this tutorial, so I will go slow here and follow closely step by step about what is happening. We can remove this and let's create a function called load module. In order to have this module available to us, we need two elements. First is the variable, is a place that will be a module. Second is a loader, is some function that will parse the whole file. As you know, it's just one long string. It will execute it and it will pack it into this module variable. Python standard library comes with a set of functions that will allow us to do it. So basically what we want to do is we want to something like import number test, except that import number test will be number test.py. Of course, this doesn't work, but we will use functions that will act just like it. First, let's get our loader. For that, we'll use import lib.machinery. The source file loader takes two arguments. The first is the name of the thing that we will load. For now, we will just call it test mod. And the second is the file. Now, the second part that we need is the variable where we'll store this module. So let's call it mod. And we will use types library for that. So what we're saying here is that this is a placeholder of a module type that is called test mod, the same as here. This is where the real magic will happen. We will tell our loader to execute the module code and to pass the code. Everything that is loaded from that file will be now as a code passed to this particular module. So we will pass it to the mod library. And now we can return the mod. Now what happens here is that this module will be treated just like this one here, like number test or bool test or whatever. And we can pass it here to the get members function. So let's turn this into a proper function. The only change is that instead of passing the number test directly to get members, what we're doing is we're passing a module that we get here as an argument. Now we can remove the number test and we can load our test in the run file. Okay, now let's run this. Boom! We are running the Boolean test. See? Running test failure, which comes from the bool test. And now if I pass the num test here, it runs the number test. Voila, this is some real Python magic here. From a string that represents the name of the file, we read the file, we execute it as a module, and we can later use it as a variable. This was the trickiest part of this video. So if you did not understand everything, go back a couple minutes and just step by step understand what each line of code here does. Currently, our test runner has just 33 lines of code, and it already does quite a bit. Today, I want to add two more functions to that. First, I want to be able to pass the path to a directory instead of just a file. Let's see what happens if we do it currently. Let's create a directory called test, and let's pass it to our runner. Alright, we have a is a directory error. We cannot open a directory. So we need to add a function that will find all the files inside a directory. First, let's move all the test files that we have there. Okay, so now we'll add a function that will go through a directory and it will go through all the files inside or even directories inside that directory, and every Python file will be added to the list of test files, and then for each test file we will load it into a module and execute. Before we do it, let's wrap this quickly into a small class so that we can keep a list of tests and the success as a state inside this class. Okay, so what I added here is I have an initializer where I have accept the path and I have an empty list of test files. And each of the function just works as it used to. The run function for now will just pass the first of the test files to the load module. Soon we will add the support for multiple files here. But first, let's load the test files. Okay, this function will accept a path and will update the list of test files here. So what do we need to do here? We need to check, okay, is this path a file? If yes, then add it to the test files. If this path is not a file but a directory, then run again this function for the whole directory. First, let's import operating system functions. And now we can do if OS is file, then we will just add it. Now else, now we need to go through all the stuff here inside this directory. So this iterative function will basically go through all directories down to the path. So here, for each element inside the list of directory path, we will just execute the same function. So it will go recursively until it goes to the very bottom where there are no more directories but just files. Let's see if that actually works. If I pass a path to a file, then it works. But if I pass a path to the directory, it throws an error. You see, the list of test files is never populated there. And let's see what is the reason. Let's print the path here. You see, what we have here is the name of the directory and the name of the file. But this path to this file is not valid because it doesn't contain the directory. So Python tries to check if this is a file. What we need is a path that will be like tests/fulltest.py. So what I need to do is when I'm going to the nested path here, I need to also add the current path so that I'm passing the whole path and not just the name of the directory of the file. Let's try now. Now you see that we have test, test full test, test pycache, etc, etc. That's already a good improvement. But you see that we are running only one test file. We are running only the Boolean test. We are not running the number test. And that's because I set here only to load a single module. So what you need to do here is we need to run over all the test files and not a single one. Let's do it. But instead of moving everything into a loop, let's just add a new function that will be called run single file. Now here in the run method, we will just iterate over all the test files. We can remove this. And now the only problem is that our success is a shared library. Let's change it into a class attribute. Let's update it. We can remove it here. We can say self success and the same here. Let's see what happens now. Alright, this is some big issue here. What happens? We have a value error. Source code string cannot contain null bytes. Okay, this is quite a tricky part. You see, if we list our test directory, we'll see that we have a pycache here. Now what is pycache? It is a directory that contains some cache Python code. It is generated when we run the code and it stays there later. Now, what you can see is that this file doesn't have anything very readable. We have some test failures, we have some test success, but it doesn't tell us a lot. So I checked how other test frameworks deal with that, and they basically ignore the pycache directory. So this is what we're going to do as well. Now when we run it, everything works, and you see that we are running multiple test files. Before we end this video, let's add just one more thing to this. I want our reporting to look a little bit better. I want the failure and success to be colorful so that we know whether we have any red flags there. For that, we'll create a small module called colors. And we'll have just 3 values: red, green, and reset. Since we're using terminal, we can use special characters that will change the color of what happens after them. These characters have special codes that I just found on the internet, so you can just see what are the other colors available, and for now I will just paste them here. So we have 3 values. Red is code 91, green is 92, and reset is code 0. And now we can use these colors. Let's import them. And let's use them when we write the messages. Let's run the test again. And you see that we have tests failed in red color. Now if we remove the test fails, let's fix this and let's comment this, and we run the test again, you will see that the test succeeded is in green color. And that's it. That's our runner file. It has 54 lines of code plus 3 lines from the colors. So in 57 lines of code, we wrote something that traverses the whole directory structure, finds the Python files, loads them as modules, runs the test, and prints the results, whether the test failed or whether it succeeded. I think that's quite a lot for such a small file. In the next video, we're going to add an assertion library. We will use a different format that says expect, and we'll add 2 functions, to equal and to not equal. I hope that you enjoyed this video, folks. If you did, make sure to subscribe to my channel, to leave some comment, and let me know what other features would you like to see, and maybe what other advanced Python tutorials would you like to watch. Take care.